Arithmetic series. When we're adding up an arithmetic sequence, so all the terms that we add up, we call it a series. Okay, so that's why we give it the name arithmetic series. So in other words, we've got our first term, our next term, our next term, and our next term, and so on and so on and so on, and we add them all up. Now, we can do it using this rule over here. S of n equals n divided by 2 to a plus n minus 1d. Now, if we know the last term, then the easiest thing to do would be to use this rule here. Example 13. For the arithmetic sequence 2, 5, 8, 11, etc., calculate the sum of the first 14 terms. Okay, so we know our A equals 2, and we know that our D, well, our D is going up by 3, so it equals 3, and we know that N equals 14 because it's 14 terms. Using our rule, the sum of N equals N divided by 2 to A plus N minus 1 times D. You can put the D first, it doesn't really matter. We want sum of the first 14 terms, so we can have 14 divided by 2. 2 times 2, which is 4, plus, I'll do my D first, 3. 14 minus 1, 14 minus 1 is 13. So I'm going to have 7. 13 times 3 is 39, plus 4, 43, times that by 7, 301. So there's the sum of the first 14 terms. For the arithmetic sequence, which goes all the way to negative 33 and it stops, find the sum of terms, the number of terms and the sum of terms. So here we want to find n for part A, the number of terms that we have. So A equals 27, and then our D is negative 4. We're taking away 4 all the time. And we know that our last term actually equals negative 33. So because we want to find n to begin with for part A, we've got T of n equals A plus n minus 1 and D. We're not going to add them up. We're just going to find the n because we don't know if it's 12 terms or 13 terms or 24 terms. So we have to know how many terms we have. So we know that we've got negative 33 for the last one. We know our A, that's 27. We don't know our n, so I'm going to leave that. Our D is negative 4, so n minus 1 times negative 4. And we're going to work all this out. So I'll get negative 60 here equals negative 4 n minus 1. This is algebraic, of course. So I get n minus 1, or equal, will be 15, and n will equal 16. So I have 16 terms. That's part A. Part B, the sum of those of the terms. So this time I want S of 16. I'll put my S of n first. This time, because I know my last term, I'm going to use this one over here. So S of 16 will be 16 divided by 2. A is 27. My last term is negative 33. I just left the plus in there, but plus and minus, of course, is minus. So I'm going to get 8 times that. When I work that out, it gives me negative 48. So S of 16, the sum of the first 6 terms is 16. Of course, I'm not writing it in words, but you should. Number 15, for the arithmetic sequence, calculate the sum of the first 25 terms. Well, we know A here, it's 3. We know our D. Our D is 3. We're adding 3 to it all the time. And we want n equal to 25. So we have S of n. We don't know our last term, so we can't use that. We're going to use this one over here, 2a plus d n minus 1. And we're doing S of 25. So we've got 25 divided by 2. 2 times a, 2 times 3 is 6. Plus my d, which is 3, 25 minus 1 is 24. And when you work all that out, you get 975. So the sum of the first 25 terms is 975. Part B, the sum of the terms in the series if S of n equals 1395. So this time they say to us that S of n, even though we know the rule, n divided by 2, 2a plus d n minus 1. When we add all them up, we're going to get 1395. So they tell us that. Okay, so we need to know n, the number of terms. So that's our n. We know our a. Our a is 3, so 2 times 3 is 6. I'm going to leave the 6 in there. Our d is 3, so plus 3. My n I don't know, n minus 1 equals 1395. Now, spanning, collecting, so I'm going to get 6, 3, n minus 3 equals 1395. So I get n divided by 2, 3, n plus 3 equals 1395. Okay, rearranging everything, I'm going to get 3n squared plus 3n equals 2790. Divide everything by 3 and bring it all on the same side, I'm going to get n squared plus n minus 930 equals 0, and n minus 30, n plus 3 equals 0. Now, of course, n has to be negative, positive, sorry, you can't have a negative n, so this part here, when I solve, is going to give me a negative n, so don't worry about that. So the only value that we're going to get is n equals 30, since n has to be greater than 0. Number 16, hardware store sells nails in a range of packed sizes. Packet A contains 50 nails, B 75, and C 100 nails, and so on. Find the number of nails in packet J. So this is part A. We know A equals 50. That's our starting value. We know that D equals, well, 25, because we're getting 25 added to it all the time. Okay. For the next one, for J, we can take n equals to 10. Therefore, T of 10 equals 50 plus 9 times 25, which when we work out is 275. So packet J will contain 275. Because remember, you've got to go A, B, C, D, J is the 10th one. That's what we got, n equal to 10. B, Lachlan buys one each of packets A to J. How many nails in total does Lachlan have? So we want to add them all up. We've got A equals 50. We know D equals 25. We even know our last term, 275. We want to use that one. So we'll use the other one, S of 10 equals 10 divided by 2, 2 times A, plus D, n minus 1. So I write the formula with everything in there. When I work all this out, I'm going to get 1625. And you should write, total from A to J is 1625 nails. C, assume he buys one of each packet starting at A. How many packets does he need to buy to have a total of 1,100 nails? So I'll do C down here. Should have done B down the bottom. C. Okay, so we've got A equals to 50, starting off with. D equals to 25, and our last term, or the sum of it, sorry, is 1,100 nails. So again, using the rule S of n, I'll do n divided by 2, 2 times 50, plus D 25, n minus 1 equals 1100. Now to do this on your calculator, I mean you have to do it long ways normally, but I'll show you on the calculator. Just go solve that for n, press your enter, and when you work that out, you're going to get n equals 8. Remember, n has to be greater than 0, so we can't have the other number, which is n equals negative 11. Example 17, the sum of the first 10 terms of an arithmetic sequence is, so that if the fourth term, so t of 4, actually equals 3 3/4, find the first term and the common difference. So here we know t of 4. T of 4 is a plus now n minus 1, so 4 minus 1 is 3d, and that will equal 3 3/4, which is 15 on 4. We also know that the sum S of n, S of 10, sorry, its first sum of the first terms is 48 3/4, so we're going to use that one there. So we got S of n equals n over 2, 2a plus d n minus 1. We've got S of 10, so we've got 10 divided by 2, 2 times a, plus 9d, and that will equal, put a colon here, 48 3/4, which is 195 over 4. And times everything by 2, I'm going to get, I'll multiply the brackets out, I'll get 10a equals 90, 10 times 9 is 90, 90 divided by 2, plus 45d equals 195 over 4. So I have two equations, right? And I'll times this one by 4, and I'll write it over here, so I get 40a plus 180 will equal 195. So equation number 1, equation number 2, and I'll do elimination. So when I times the first one by 40, and I'll times the second one by 4, and when I work all that out, I end up getting 60d equals 45, so d equals 3/4. And of course I'll substitute that, d equals 3/4, into equation number 1, and I'll get a equals 15 on 4 minus 9 on 4, which give me 6 on 4, which equals 3 on 2. So first term is 3 on 2, and common difference, excuse the bell, equals, where's my d, common difference equals 3/4. Thought I was going to finish. Let's force it.